Hello everyone, my name is Joel Dunay and this is my official unofficial solution for the network state exam. Now it's the 11th topic, which is about addressing in networks. In which OSI layer is addressing needed and why? What are the characteristics of these addressing? So basically here we are differentiating two layers because we all know the 7 layers from top to down: the application representation, session transport, network data link, and the physical layer at the bottom. So if we go from bottom, then the first one is the physical layer where the addressing is important, and then the network layer, the second one where addressing is important. So how does it look like? The physical layer, as I said, has two sublayers, the LLC and the MAC layer, and the LLC does the encapsulation. The encapsulation, meanwhile, the MAC controls the medium. So we are talking about frames, and it's layer 2, so we are talking about switches. So it is important that in this case, if we have IP addresses, then we really don't care. I mean, the switches don't care because they are not working with IP addresses. If they have an IP address, then they will do an address resolution protocol in order to get the physical MAC address of a specific device. So that's the address resolution protocol. So how does it looks like? It's quite simple that the physical MAC address always changes, so the physical MAC address goes from one switch to another, then the MAC address destination will change again. Meanwhile, the IP address will remain unchanged during the transmission. So here you can tell how the switches are working, that they are using frames. By default, when you plug in a new switch, then the switch MAC or CAM table is empty. Therefore, when it will receive a frame, it will save its port on the or save the MAC address of the frame and on the ingress port on each on with it came in, and it will flood out, save it in its MAC table, and will flood out on all other ports. So for example, next time when a frame will come and the destination will point to that one, then it will to the previously saved link, then it will not send out a broadcast but will send out a unicast directly to the host, for example. And of course, it's important that these entries, I mean, in the MAC table, are only stored for 5 minutes. And if there is a MAC address that's saved with a port and another frame comes on that port, then it will be up. I mean, there is a timer, and the timer will be updated. So I believe that's all about the switches and about the physical MAC addresses. And now let's switch to the IP addresses, because that's the layer 3, the network layer, where we are talking about routers. So we are talking about forwarding packets from one network to another and based on their routing table. So here the actual IP address is really important. I mean, not actual, the destination IP address is really important. I've told it several times in previous videos that how the transmission looks like. A router will receive a packet, it will de-encapsulate until the network layer checks the destination IP address. Based on it, it will check its routing table and will forward to the next router or forward it directly to the destination. It will re-encapsulate till the data link layer, and then it will be sent out bit by bit. So basically, what is important that the IP address will not change, that will remain always, and we are using the IP address to identify the host and the destination, the source and the destination, and the MAC addresses are used just to simply forward traffic. The structure of address used in LAN and local area networks and wide area network systems with examples. I believe I said it once in one of the previous videos that we can have private and public IP addresses, and imagine that there is the internal network where we have a private IP address and there is an outside internet untrusted network. So what's going to happen is really simple. When we would like to send the traffic from the private to the public, the router will detect that the source is a private IP address, therefore it will drop it and not forward it to the internet by default. Of course, if we are using network address translation, then this problem can be solved with this simple approach. So when the router will get it, it will give a public IP address to it and it will able to communicate, the host is able to communicate with the internet as well. Why physical and logical addresses are needed, I talked about this. The aim, the requirements and realization of the addressing in the third layer, I've talked about this, that we identify the source and destination and how the transmission looks like. So we re-encapsulate, if we checks the encapsulate and then re-encapsulate and send to the destination. The different components of the addresses in the third layer, the classful and classless addressing, different components of the addresses. I don't know what does it mean. Classful and classless addressing is quite simple because back I don't know when, but we had by default three classes and they had the three base subnet mask, the /8, the /16. The /8 was the class A, the /16 was the class B, and the /24 was the class C. And you don't have to know its ranges because I didn't know, and I had to talk about classful addressing as well, but this was not my topic. So by simply you can come up that the problem of this classful is we are wasting IP addresses. So in a class A we are having more than 60 million host IP addresses. At class B we are having approximately more than 65,000 IP addresses, and at class C we are having only 8 bits, so we are having approximately 255 host IP addresses. So imagine the following example, because this is cool. Imagine that you are building or a new startup company. There is a new startup company, and what's going to happen? There are 10 workers, for example. This company will require or would like to get IP addresses in order them to use. And what's going to happen? They will get the class C. They will get more than 250 IP addresses, but there are only 10 workers. So let's say that they will use maximum up to 20 IP addresses, so they are going to waste more than 200 IP addresses. This was the death of the classful IP addresses, that will wasted a lot of IP addresses. So this is a small or a little example, but imagine that this company has evolved under 5 years, for example, and now there are not 10 but 300 workers. Now class C will not be suitable for them because there are not enough IP addresses for them, so they will get a class B mask, and there will be more than 65,000 host IP addresses, but they are going to use only 300 out of that. So by comparing the wasted IP addresses, the previous 200 is nothing to this more than 60,000 IP addresses. So you can see that the problem is that if they get a class B, then nobody or others cannot use that remaining 60,000 or more than 60,000. So that's the problem with the classful addressing. And that's why the classless addressing was introduced, because classless addressing allows to not have the three basic subnets, the /8, 16, and 24, but having variable subnet masks, like we can have /1, 2, 3, 4, 5, and even 30. And of course the advantage of this, that we can have our requirements. So if we would like to need 30 IP addresses, then we can get a subnet mask where we will get approximately that much amount of IP addresses, therefore we are not going to waste too much there. The characteristics of IPv6 addressing, different types of IPv6 addresses. I've said it in previous video as well that I'm going to talk about this at the IPv6 topic, therefore I'm not going to tell it here, but after you see that video you can tell about it now. Okay, the connection between the data link layer and network layer addresses, the need for connection and its implementation. I've talked already about this. It's the MAC address and the IP address, and of course the connection is that the network layer is softwarely handled, and the sublayer, the sub-logical layer at the data link layer handles the software and the interface. So that's all about the 11th topic. I mainly covered everything, and again, if I missed something or said something wrong, then I don't really care, and subscribe to my channel.